Yuanhao will be talking about the TinyML hit image face recognition on Wio Terminal. And Yuanhao is a senior undergraduate student of Southern University of Science and Technology, major in robotics engineering. And since high school, he has exposure to various of embedded hardware. He was won the champion of the World Robotic Developer Competition and the second class prize of the China University Robotic Competition. And during his internship at a Seed Studio, he made a lot of imaginative and innovative TinyML demo based on Edge Impulse and Wio Terminal. So then how this is your floor?
Yes, it is my slide. Thank you, Chen, and hello everyone. I'm Zhou Yuanhao, an undergraduate student in Southern University of Science and Technology. It is a pleasure to give my talk on TinyML. We're gonna talk about one of my internship project at Seed Studio. Please know that it is not a research or project at my college, but more like an application demo of Seed Studio. As you see, the title of my talk is about heat image recognition using TinyML on Wio Terminal. Let's start with a video demo. As you can see in the screen, a Wio Terminal can recognize different people with heat image. The girl labeled in LHY, me labeled in face, and the man labeled in YJM. Yep. This is a small CV demo using TinyML. To begin our talk, let's discuss the necessity. Face-based biometric recognition needs fewer additional actions than fingerprint-based biometrics and offers better privacy, for example, the success of Face ID. But nowadays, face recognition schemes are usually based on RGB or RGBD information, which can be easily copied, bringing the problem of living body judgment. Not only that, platforms that process RGB facial recognition usually requires more computing power or cannot operate offline. So a low-cost, low computing power demand, real-time and offline computing solution is needed. After that, let's talk about the possibility. To our skin, as all we know, living things gives off heat, which indicates that thermal imaging can automatically exclude non-living objects such as photographs. And the human face contains multiple muscles, eyeballs, noses, and other features, which will not only shape our face in RGB graph, but also in thermal graph. Because of the uniqueness of the face, the temperature gradient of the thermal feature is also unique, which brings us the possibility of using thermal imaging for face recognition. So we realize our idea on the following hardware, which are Seed Wio Terminal with an ARSAMD51 MCU based on ARM Cortex-M4 core and a Seed Groove thermal imaging camera MLX 640 with 32 times 24 pixel resolution. You see, the platform we choose is not originally designed for computer vision application, but we managed to use sensor with lower resolution to achieve the goal. We also designed our software stack based on a rather simple structure. We use Arduino IDE for programming and Edge Impulse for model training and converting, which makes almost everyone easy to access. As I know, Seed is also developing the CodeCraft model based on this demo, making the threshold even lower. For the data collection step, because of the edge impulse daemon does not support the graphical input, we decide to store the heat image in SD card in JPEG format so that we can easily use edge impulse uploader to upload these images. By the way, there's also some data set of heat image face recognition for training as shown. For a better training output, we can download the data set and then downsample it to the same image size and then upload it to edge impulse. So after collecting the data, we can plug the SD card to our computer. If everything goes well, the image will be shown in grayscale, and the final name indicates the label, so that we can upload it directly to edge impulse. We designed a simple impulse structure. We input the raw image as data input and use the neural network classifier to classify the data. In the classifier, I try to use a VGG-like network with 2D convolution layer and pooling layer appeared in sequence. At first, I tried 5 layers of convolution and pooling layer pair, but it turned out that even 2 layers is enough to well classify my data set. We move to the inferencing part. While writing the program, I found out that edge impulse API only supports input with process as shown, which might be confusing while reading. At last, we get a result on Wio Terminal, and we can inference at a speed about 3 to 4 FPS. And we get a very high accuracy on our validation set. Let's use a video to overview the sequence and the hardware we use. This is the hardware we use. And then we wire them all up and plug the SD card. Thanks to the Groove ecosystem, the work can be done very easily. And here is the entire hardware stack. After that, we open the data collection stack. Change the label string if you want, and then select the correct development board and configure the CPU. Boost it up to 200 megahertz for better performance. And then we can choose the optimization level. After flashing the sketch, we can see that the heat image appears in our screen. And we can press the button to collect our face feature. Please mind that we should hold the camera steadily to prevent the motion blur from corrupting our dataset. And then we need to record the environmental feature. And then we can upload it all to edge impulse from SD card. We can view the heat image in grayscale. Yep, it is the grayscale image. After that, we create an impulse sequence like this. Use raw image data as input and use NN classifier to classify the data. And it is the input feature tab. And it is the neural network structure. And the result. And then we can deploy it using the Arduino lab. And we include the Arduino lib, just download it and flash it to Wio Terminal. And here I'm showing you the process of data to let Edge Impulse API to accept it. And the compiling may take a long time. You need to be patient. And it finally works to recognizing the environment and my face and other my colleague's face. Okay, the demo is quite simple and crude, to be honest. I haven't tested in more complex scenarios, but it opens up a new possibility of everyone using TinyML with certain tricks to achieve different tasks. In my further intention, I think we can explore more about thermal imaging in different tasks, like disease diagnostics, and perform more tests in different temperatures and other actual application scenarios. We can also use transfer learning to make people train the model more easily. And it is the my GitHub open source code. And that's all of my talk. Thank you, everyone.
Okay, that's a very great talk and very interesting. So as we know that there is a lot of face recognition technology, for example, use the image or use the depth information to do the recognition. But your talk is very special for just using the heat. And just one question: how about the environment temperature impact to your recognition result? Is there do you have any number or to do some experiments about this?
I actually do some experiments. When I first finished this demo, it is in summer, and it works fine. And now it is winter, and it works fine too.
Okay. So you mean the weather or the temperature, indoor, outdoor temperature is a limited impact to your recognition result, right?
Yes.
Okay. I think the other question is that in your presentation you mentioned you use the VGGNet in your inference, right?
It is a VGG-like net. It is a simplified VGG-net.
Yes, I'm just curious about because your processor just the info level, just you mentioned. So you should do a lot of trimming or shrink model size shrink. Can you talk more about that?
Basically, it was mostly done on Edge Impulse platform. I just set the model architecture like this, and then it will automatically do the training and evaluation.
Okay. So the other question is that in your algorithm, do you need any temperature calibration to improve your accuracy? And after some time, after you just to tuning the model to adapt to do the calibration or not, because we all know that,
in the data set of my sensor, I found that it is pre-calibrated in the factory. I think it is enough for the daily use.
Okay, so you means you do not need any calibration after you training your model. You just do the inference, right?
Mm-hmm.
Okay. Okay. So thanks again. It's a very good talk. Yes.
Thank you to our strategic partners who supported us, especially some of the key partners here. We've got ARM, who help with hardware and software. The what's called Edge Impulse for developers on the libraries. Qualcomm Advanced AI Research as well for their support in edge computing. Cynthia around hardware and ML training pipelines. So definitely thank you as well. Platinum sponsors, Reality AI for advanced sensing with product and TinyML. Renesas for microcontrollers and microcomputers. Our gold sponsors, Sladen.ai, Adaptive AI for the Intelligent Edge. Maxim Integrated, enabling edge intelligent devices. Seed Hardware, who also had present today. I'll quickly go back to them. Thank you once again for all your support. SenseML, build smart IoT sensor devices for data. SynthSets, and our silver sponsors. So thank you once again. It's been a great few days. Look forward to 2022, as mentioned before, and hopefully see you at some of the future TinyML events. Thank you.